house, we have your meter housing, your service mast, and your masthead. What we look for when we're doing the inspection is you have these wires bundled with a little bit of a loop, and that's just so that you don't have, when you have rain hitting, you don't get moisture running down this pipe. So if I took the service and I brought it up over here, all the water would feed down in here, and you'd be introducing water into your electric service. So when you come into the service, you want to see a drip loop to the wire. And then you usually have your electric service coming in, and there's a clamp that's bracketing that service wire to the house, and then you have your connections over here for your good service. This one doesn't have an example of it, but we also want to have the grounding rod now. There's a pipe that extends down there. Copper pipe is hammered down into the ground, typically about 8 feet down. And if the system basically has a current that's running, you have natural ground that is sending that current and dissipating that into the soil. The other way to do it, and you'll see on this side, is we'll take that ground and we'll connect it to your water supply. A lot of times on older houses, this is your grounding connector, grounding wire that runs into the system. And you can see the grounding wire come in right through here, this green wire. And this attaches to your electrical service in here, bus bar down here. There's different ways that electricity flows. The grounding allows for basically, I'm plugging something in. Right now, if electricity doesn't have a place for it to go, it's going to try and find a natural ground, the easiest path for electricity to go. So if I'm standing in water and I'm plugging something in, it's going to want to ground through me. And that's where you get an electrical shock. What this does is basically take that electricity, introduces a perfect path for it to flow to this metal pipe, which extends into your city water supply, and that dissipates the electricity. And the one thing, though, that we're looking for now is you have a lot of municipalities that are using plastic for the main water supply, so that's where the grounding rod becomes much more important. Because you want to have that electricity, you give it two options to go. You have the grounding rod and you have the ground to the main water supply. We have an example here of breakers, circuit breakers, and here we have fuses. A lot of times we'll have people that pop fuses, and they'll come in. This is a 15 amp fuse. Oh, I keep popping fuses, I'm just going to pop in a 20 amp this time instead of a 15. And then the microwave doesn't pop the fuse in. But what's happening is you're introducing more heat to your wires. And the wires are sized in different gauges. This right here is a 14 gauge wire. Thicker, it gets lower. This is a 12, 10, 8. This right over here is a 3. And this should be a 1 on. And it is. These right here, if you see these open in the basement area, this is just foam, low voltage cable. But this wiring basically, if I'm throwing a 20 amp fuse or breaker on this wire is allowed to heat up to a greater temperature before it actually could trip that 20. Each time you do that, that can slowly deteriorate the wire.
What exactly does a fuse do? Why is it in the system?
It controls the heat. So if the wire overheats, the fuse overheats, or the breaker overheats, and it trips. So it limits the heat. So if you get too much heat on this wire, it'll melt.
Which could
cause a fire. So somebody who comes in and they throw in the 20 amp fuse where it should have the 15, that could be allowing that wiring. It might not be in this spot, it could be at a junction where you have two wires connected. The wires are spliced, that's a weak point, and maybe it'll melt that connector that's on there. And then you have arcing within that metal and you can have a fire. So the cost of overfusing is can be great, obviously, with the fire, but that's one thing that we look for. We'll take off the electrical panel. We'll look at the wire sizing within the panel, and I'll let you know what the conditions are within here to make sure that the wiring is proper. We have a couple of specialized breakers on here. One is, this one over here, power. One is a GFCI breaker. This might be to a hot tub. If you've ever been in your kitchen or your bathroom, you have an outlet in here called a GFCI outlet. It's a ground fault circuit interrupt. What it does is it senses milliamps, I believe at 5 milliamps, and it will trip. So if my hand is wet, maybe there's a fray in the cord, I go to plug it in, there's a little bit of shock that will run through there, but at 5 milliamps, it'll shut off right away, you won't even feel it, and it'll cut the power. So it's a relatively inexpensive way to actually prevent electrical shock. It is, but they've expanded it, and they keep on expanding it, and it used to be within 6 feet of a plumbing fixture. Now it's pretty much any counter area in the kitchen. Yeah. Because I figured that if you're in the kitchen, your hand can be wet anywhere. So about $8, $10 an outlet. In general, electrician will charge you about $40 per outlet to change over outlets for GFCI, maybe $30, $35 for standard outlets. So that's something that they include in their cost. But this is relatively inexpensive, and this breaker is the same thing as this, but it's on the actual breaker. So it'll do the same sensing that this does, and this one's specific for a jacuzzi tub or a hot tub. Sometimes you'll have a hydro spa tub, and the motor access will be in a little bit of a difficult place. And when you have that, somebody's got to actually take off the panel and get into where the jacuzzi tub is connected with the cord and test that button. You want to test this, and they say every 30 days. You know, if you don't use it every 6 months, then maybe before you use it, you actually test it, make sure that it trips. But they put them in the main panel because it's a lot easier for people to actually trip when you use them. So if you have a hydro spa and you want to make sure this operational, you typically go into your main panel, come in, you'll hit the button, the unit will trip. That indicates that you still have a properly functioning GFCI. Questions or?
If your microwave is tripping at, and you don't want to put in a higher fuse because it would melt the wire, what do you do?
If you have your, if you have your microwave tripping it, you don't have enough circuits in the kitchen usually, or they're not laid out properly. When you go into an older house, that's usually what happens. You know, the wiring within the kitchen wasn't designed for a dishwasher, a disposal, a microwave. So when they add those, they're supposed to add circuits. You have two options. You can have a separate circuit for that microwave, or the electrician can bring in a larger wire to service those appliances. Typically with a microwave, you might have the microwave and the range together on a circuit. With a disposal and dishwasher, you might have that on a separate circuit. And then you want to have two separate circuits for the counter outlets. And that's for a mixer.
Those things in the box, those are circuits?
These are circuit breakers, correct?
Circuit breakers. So what is a circuit?
What is the wire?
Each breaker is one circuit.
Yeah, each one, say this is my dishwasher and disposal.
Right.
This is my microwave and my range. This is the lights in the kitchen. So each one has their own power supply. Rather than
So then sorry, I didn't mean to cut you off. But then that power supply runs to an outlet.
This can run, it's going to be to an outlet. Your dishwasher might not be an outlet, it might be a direct wire connection. Your disposal, same thing, where it's just a service which is available. And basically your electrical current and your grounding are within that.